In our last example, we have Donovan. He's estimating the height of the second floor in the mall. He sights the second floor at a 10-degree angle of elevation. I can see the 10 degrees right here. He then steps forward 50 feet. So he walks forward 50 feet and until he's 5.5 feet away from the wall. If Donovan's line of sight is 66 inches above the ground, excuse me, at what angle of elevation does he sight the second floor? So in other words, we're looking for y here, aren't we? Now, when I start here, it kind of looks like I can't do y, can I? Because I don't have enough information. I'm missing the x, I'm missing the y. I know 5.5, but I need two pieces of information to solve this problem. But what I'm going to do is I'm going to look at the original triangle. And in the original triangle, I can find x, can't I? Because I know my angle of elevation. I know the whole length, which is going to be 55.5 because we add them together. Maybe I'll write that down here. So my whole length is 55.5 feet. That I have enough to solve. And then once I find x, then I can use x in the small triangle to find y. So let's start here. What do I know? I know 10 degrees. I know the adjacent side. And I know x is my opposite. So I'm going to use tangent again to solve for x. So I'm going to say the tangent, make that, I want to be able to see my picture there. There we go. So I'm going to say the tangent of 10 degrees equals the opposite, which is x, over the adjacent, which is 55.5. So I multiply both sides by 55.5. The exact answer of x is 10 times the tangent of 55.5. And since I'm going to use this answer in the next step, I'm going to take it out a few decimals. So if I take 10 times the tangent of 55.5, I'm not going to just write 15. I'm going to say 14.55. Now I'm going to use that to find my answer. What am I doing? I just want to get, oh, there we go. Forgot to put the plus sign. Okay. Now I know, now I'm going to look at my small triangle. In my small triangle, I know x is 14.55. I know my adjacent is 5.55, so I'm going to use tangent again. So I'm going to say the tangent of y equals my opposite equals x, which is 14.55. And I'll divide by 5.55, or 5.5. So in other words, the measure of angle y is going to be the inverse tangent of 14.55 divided by 5.5. So the measure of angle y, I'm going to say, is the inverse tangent of 14.55. Well, I've got this in my calculator, so I'm just going to press answer. And I'll divide that by 5.5. And I get about 69 degrees. Notice, we never actually use the fact that he was 66 inches above the ground. I might use that fact if I was trying to find the height of the second floor, but that's not what they're asking. And it also makes sense. Notice he starts at 10 degrees. As he walks closer, he's got to tilt his head more, so my angle of elevation is increasing. Now, in the next part, let's take a look at this triangle. We know to find the area of a triangle, it's 1/2 base times height. But notice, I don't know the height of this triangle. So I'm going to come up with an expression using trigonometry to find the height. So if I drop the height down, this will be h. I'm going to look at angle A here. I could use any angle. I'm going to use it angle A. Well, in angle A, h is the opposite, and B is my whole length, so I'm not going to use B. I'm going to use C. And A isn't in my triangle on the left, so that's going to make my hypotenuse, isn't it? So I can say on this problem, and I got to be careful because angle A is not the area. I'm going to go back here, and I'm going to erase A here. I'm going to write area, so we don't get those two mixed up. So I'm going to say this: the sine of angle A equals h over c. Now I want to come up with an expression for h, so I want to multiply by c. So h is c times the sine of A. So if I write that in my area formula, I'm going to say 1/2 times B times C times the sine of A. And that is how we find the area of a triangle. If I know an angle, but I don't know the height, I'm going to look at my angle, and I'm going to surround it by the two letters, so it's side angle side. So I'm going to say BC times the sine of A. Now that works with any angle. So if I would do angle C, I would say my two letters around angle C are A and B, so I'd say 1/2 AB sine C. We're just going to extend that out. And if I was doing angle B, I would say the area is 1/2. The two sides around angle B are A and C, and that would be the sine of angle B. So there is our formula that we've derived for the area of any triangle. We call those oblique triangles where they're not right triangles. One of the few times in this chapter we're not going to be looking at right triangles. We're going to make them into right triangles so we can do it though.